All right, we're gonna do it again. This time we're gonna do it with the distance formula. Distance formula should be something that you recognize. We're gonna run through a couple problems and you're gonna be good to go on your own. So let's start with this first one. It says the endpoints of PQ are P, -3, 1, and Q, 4, 25. We're gonna find the length of PQ. So we're gonna do the same thing that we did with the midpoint formula. We're gonna label our x1, y1, x2, y2. So our first set of points will label x1 and y1. So -3, x1, 1 is y1. And then we'll label x2 and y2. So 4, x2, that's y2. And then all we do is transfer that information over. So x1 is -3, x2 is 4, y1 is 1, and y2 is 25. And so now all we have to do is, we'll go back up here to this formula, and we plug it in. So first comes x2. x2 is 4. And then x1, which is a -3. Don't forget the negative sign. And then we have y2, which is 25. And y1, which is 1. And now the next step here, we get distance equals square root 4 minus a -3, that's plus plus. That's 7 squared, plus 25 minus 1 is 24 squared. And so from this point right here, you can actually plug that into your calculator. As long as you put the square root first, so you type in square root of, and then you would do 7 squared plus 24 squared. Now, if you want to see the steps, you get right here to 625. But if you plug it all in, like I said, you'll end up getting the square root of this to be 25. So really, you don't have to do this step right here if you know how to plug it in from this point on. If you need help with that, ask me or Mr. Siegel, and we can show you further. So here, let's look at another one of these problems. Number 2. It says, what is the distance between the points -3, 2 and 1, 0? Well, guess what? We're going to follow the same process we did before. So here, we got x1, y1, x2, y2. Let's transfer that over. So x1 is -3. x2 is 1. Very good. y1 is, right here, you see that y1? That's 2. And y2 is 0. And so now, if you remember the equation from above, I'll scroll up quick so you can see it. Remember, it's x2 minus x1, y2 minus y1. We'll plug those in. So x2 comes first, so that's 1, minus x1, so -3, y2, which is going to give us 0, and y1, which is 2. And so now, once again, you're going to do a little simplifying here to make it nice and clean. Minus a negative, that's plus plus. So we get 4 squared plus, and you're going to get -2 squared. And now, once again, like I said before, you're going to plug this right into your calculator, and you're going to get, oh, and you're going to say, oh no, Mr. Elizondo, I got distance equals 4.47214. You're going to look at your multiple choice answers, and you're going to go, that's not any of the answers. What am I going to do? Well, don't worry, because instead of showing you another way, we'll just do this simple. You can plug in each one of these into your calculator, and then ask yourself, which one of them looks the same? So if you do 2 root 2 into your calculator, number 1, you get 2.8283. Well, that's not right. So if you go to number 2, it's 2 root 3. We plug that in, we get 3.46. We're getting closer, but that's not right. Number 3 is 5 root 2. And when we do that one, we get 7.07. That's not right. Let's check though, make sure this last one works. 2 root 5. And we get, it ends up coming out to be 4.47214. So, sometimes they're going to ask you to simplify. If it's a multiple choice question, you can do it just like this and you'll be fine. So your actual answer is 2 root 5. But for multiple choice purposes, you can do it just like this and you'll be fine. All right, so this is your practice side. And see, here's question 1. We're going to skip that one. I think you can do that on your own. Let's do question 2 because I think these square root ones could confuse people. So I want to make sure you're all okay on this before we let you loose. So once again, what is the length of the line segment? Whose endpoint? So you're finding the distance. Whenever you see that length of a line segment, it's your distance formula. So we'll do the same thing we've been doing. x1, y1, x2, y2. We'll transfer that information over here. So x1's -1, x2 is 7, y1 is 9, and y2 is 4. Now here, I didn't give you the distance formula because I hope you know it by now, maybe. But remember, it's your x2 minus your x1 squared. Here, I'll write it out for you. x2 minus x1 squared plus y2 minus y1 squared. And then we're just going to plug things in, right? So we'll get distance equals, and then our x2 is what? 7. Nice job. 7 minus, our x1's -1. So don't forget to add that sign in there. It's minus a -1 squared plus, and for y2 we have 4 minus 9 squared. All right. I'm going to move this right over here, so follow along with me. 7 minus a -1, that's plus plus. So that's the square root of, and we have 8 squared plus 4 minus 9 is going to give us a -5 squared. Now remember, I said right here, you can plug this right into your calculator, and then we're going to compare answers. So when we plug this into our calculator, so the distance is going to equal 9.43398. All right, and then we just compare. And oh, one thing I forgot to mention. You see this -5 right here? When you put this in your calculator, make sure you put that -5 in parentheses before you square it, just to keep the sign the same. So here, we'll do square root of 61, and that gives us 7.8 something. That's no good. Let's do square root of 89. That gives us 9.43398. So our answer is number 2. Now a quick note about some of the problems at the end. Now some of them are challenges, okay? I'm going to jump ahead in the video really quick. So if you move ahead to Regents level, you see some of these say find in simplest radical form, like this 87 right here, and this last challenge problem right here. Try your best. See if you can't figure them out. But by all means, you can plug it into your calculator, show us that final answer. As long as you can get to that step, you're going to be just fine. And with that said, I wish you the best of luck on the distance formula. And remember, you got this. Believe in yourself.